Good morning. My name is Shruthi, and I will be describing an assignment that my project partner Kristen and I did for a class on geographic information systems. For the assignment, we created an application that uses a regression model to help the Chicago Health Department prioritize their inspections. I will run you through our mock presentation. Good morning. My name is Shruthi, and I represent Project Smart Inspect. My project partner, Kristen, and myself developed a model run inspection system that pulls from various open source data for Chicago. Our aim is to best predict which restaurants are likely to fail a health inspection, such that you, as health inspectors, can focus on one thing: keeping the people of Chicago safe. As a department, why would you want to pick Smart Inspect? Well, today, the inspection process, from carrying out inspections to billing the establishment owners, is very complex. Deciding which restaurants to inspect is based on a combination of fixed calendars, convenience, and inspector intuition. It also involves a lot of paperwork. By integrating this to one system, we will provide every department involved with the tools they need to effectively monitor restaurants in Chicago. So how does our system work? As an end user, you can choose which group you want to log in as. Let's start with the inspectors. There are three main processes you can carry out as an inspector, highlighted as tabs in blue. An interactive map will show you where you and all the restaurants that require inspections are. Every restaurant is color-coded according to its probability of failing an inspection. The table to your left shows all the restaurants ranked by distance that you can also sort alphabetically or by probability score. You can either click on the restaurant in the map or its title in the table to pull up its details. Let's take a look at that screen. The second tab provides current and past details of the restaurant that you pick, and a new restaurant can be picked using the interactive map at this scale. When you decide which restaurant you wish to inspect, a third tab with the inspection form will open up that allows you to complete and send the report in real time. In this way, the system provides you a quick and comprehensive view of a restaurant over time, and you can build on this with the current inspection results. So what's in it for you as a supervisor? As a supervisor, you can access inspections that are currently being carried out. By navigating to a neighborhood on the interactive map, you can access real-time information about daily inspections. Navigating to a completed inspection will take you to the Sign Me Off tab that opens the inspections requiring your approval. 3 types of results have been coded into the system. You can even keep track of the billing data of a restaurant that is linked to the Finalized tab. What if you want to use the data as a third interested party? Navigating to the Others tab on the home screen will show you a list of possible users of the application, and each one will open up ways that the user can use this data. For example, the billing department can use the application to track invoices and payments in real time. In this way, the system supports multiple users. So what's happening behind this user interface? To begin with, we asked ourselves what conditions might make an establishment fail a health inspection, and came up with 38 potential variables from the Chicago inspection form and available open source data in Chicago. We built the dataset for health inspections in 2014 and 2015. Using the 2014 data, we ran the model in R using backwards stepwise regression. The resulting model included 22 of the 38 variables and outputted the probability of every restaurant failing a health inspection. Once we perfected the model, we applied it for 2015 health inspection data to see how well our model performed. How do we know if we have a good model? In order to do so, we created 4 goodness of fit indicators. The McFadden pseudo R-square is an indicator of variable significance, and ours came in just shy of the 0.2 cutoff that is used to indicate a good model. The curve to your right shows the relationship between the restaurants that passed and those who failed. The fact that the curve pulls to your upper left is indicative of a predictive accuracy of 71% that allows the model enough flexibility to be used for other data sets and is better than a random 50-50 chance. The fourth goodness of fit measure is the confusion matrix that tells you how your model performed for a specific threshold. A 50% threshold is commonly used, so restaurants with a probability score of 50% or greater will be classified as failed. However, when the stakes are high, as in this case, we want to make sure we are catching as many dangerous restaurants as possible. Therefore, in addition to 50%, we also looked at the 40% threshold. In both cases, the hit rate is roughly comparable, but the critical wrong predictions reduced from 21% to 15% at a 40% threshold. In conclusion, while we know that inspections today are carried out in a smart and comprehensive manner, our model can help refine what is already a great system. Ultimately, our aim, like yours, is to create a healthier Chicago, and we believe that smarter inspections can go a long way in achieving this goal. Together, let us welcome a world of smarter inspections and healthier cities. Thank you.